Okay, so last week we talked about equations that had exponential expressions in them, okay? And we're moving on into equations with logs. And before we actually can solve log equations, we're going to have to remember some of the properties with the logs. And we did go over these in class, but I wanted to go over them with you again, okay? First of all, remember, logs are very closely related to exponential expressions. They're basically the same thing written in a different way, okay? So everybody remembers the rule for multiplying monomials with exponents. For instance, let's say I wanted to multiply x to the fourth times x to the third. We all know that you add the exponents there, okay? And we get x to the seventh. And in a log, you have the same rule, okay? So what they call this is expansion, okay? So you're taking a condensed log and you're rewriting it as an expanded log. You can go back and forth with that, okay? You can take an expanded log and condense it into a smaller expression, okay? But the point is that when you see multiplication of m and n, then you can separate it with addition and vice versa, okay? So I hope y'all remember that. Now, on the other expression, we actually see some division. And just like with our exponents, when we divide, we actually can subtract the exponents. Same thing with the log. So this is the expanded version. This is the condensed version. Keep it in the right order because, as you remember, division, order matters in division, okay? All right. And with your, first of all, that was called the product property, the first one. The next one's called the quotient property. That makes sense, okay? The next property is called the power property. And that just says that if you have a power at the end of your log there, you can rewrite it as a multiplication in front of the log. Okay, that's different than the product property up here where we were multiplying m and n. You're actually multiplying it to the front. It has to go out front. Okay, and then we have what we call the equality property, which is pretty easy to understand. Basically, if you have log base b of m and it equals log base b of n, that must mean that m and n are equal. That makes sense, okay? All right. And here's some examples over here of how you might use this, okay? So here you have the condensed version where 9 is multiplied to x, and when you rewrite it, they just rewrite it. Now they make two separate logs with base 3. They have log base 3 of 9 plus log base 3 of x, okay? And remember, you can go in the opposite direction as well. You can start with it being expanded, and you can condense it. That's probably what we're going to do mostly. All right, in the quotient example, you've got log base 1/4 of 4 over 5, which means division, right? So we can keep the base 1/4, log base 1/4 of 4 minus log base 1/4 of 5. Notice they kept both logs the same and just rewrote the expression with the minus sign, keeping it in the right order, okay? In your power property, you've got log base 2 of 8 to the x power. That power can move out front and be rewritten as x times log base 2 of 8. And then this is where we really use the equality property. If you notice, we have log base 8 of 3x minus 4 and equal to log base 8 of 5x plus 2. Since we know these are the same, you can actually just drop them, similar to the exponential equations we did last week, and you can set those two equal to each other. Now, what does that do for you? That's going to allow you to solve this equation, okay? So on and so forth, okay? So all of these properties are going to help us solve equations in the next examples. Okay, so I'm going to move forward into solving some of these equations, okay? Keeping in mind my properties that I just talked about, okay? First of all, in number 1, you see that you have x plus 5 is equal to log base 4 of 256. Okay, so what we have in number 1 is we have an equation But it doesn't have logs on both sides, okay? So we're not going to be able to just drop the log base 4. We're going to have to actually use it. So when you see an equation like this, what you want to do is just take it and rewrite it in exponential form, okay? So log base 4, we know the base is 4. Remember, log is bay. This is the base. This is the answer. So we're going to set it equal to 256. And on the other side is the actual exponent, okay? So we're going to use x plus 5 as the exponent for 4. All right, and you may be thinking, that looks familiar. Well, that is exactly what we solved last week, okay? And what we want to do is be able to rewrite 256 as a base of 4. And we can easily do that because 4 to the 4th power is 256. So we're going to take 256 and rewrite it as 4 to the 4th power. And at that moment, now we see that we have the same base on both sides of the equation. We're able to drop it. Set our x plus 5 equal to 4 and solve. So in this case, x is equal to -1. Alrighty, which if you did plug that in, -1 plus 5 would be 4, and that would be true. Okay, so do you see, if you have logs on both sides, you are able to drop the logs, but if you don't have logs on both sides, you're going to need to rewrite it as an exponential. Okay, let's look at another one. For instance, let's look at number 5. In this problem, it's completely different than number 1. You've got log base 13 on both sides. So I really like this problem because I can just drop the log. Okay, we know if they're equal to each other, then the x squared minus 4 is also equal to the other side. So all we have to do is set this up and solve. Okay, so there's no rearranging need to be done. We do need to solve it as a quadratic. So we're gonna, I guess, factors probably the easiest way. We're gonna say x squared minus 3x minus 4. Looks like that could be rewritten as x minus 4 and x plus 1, leaving us x equal to 4 and x equal to -1. And so more than likely one of these answers actually does not work. So we're going to have to plug them in and try to see which one actually works and which one doesn't. Remember, if you get a legitimate answer but it doesn't work when you plug it in, that's called an extraneous solution. Okay, so I'm going to plug in 4 and make sure it makes sense. So 4 squared minus 4 would be 16 minus 4, which would be 12. So we would have log base 13 of 12 on that side. And then when you plug in 4, 4 times 3 is also 12. So that one definitely works out. That's true. Log base 13 of 12 is equal to log base 13 of 12. Okay, so let's try the -1 when we plug it in. So if I plug in a -1 right here and square it, that's going to be a +1. 1 minus 4 is -3. So we'd end up with log base 13 of -3. Okay. Set equal to, over here, if I plug in a -1, we'd also get log base 13 of -3. So you're probably thinking like, oh, wow, they equal, so that must be a true answer. But in fact, it's not, because if you think about it, the 13 is the base, okay? We're saying 13 is the base, and some exponent that you would plug in would make it equal -3, okay? I'm trying to write this out for y'all. So you're trying to say, okay, 13 is the base, and some exponent would make it equal -3. Well, you cannot go from having a positive base to a negative base by using any exponent. Even a negative exponent is not going to change the number to a negative. It's going to make it into a fraction, okay? So in this case, x equal to -1 is not a solution, okay? So you don't want to have a negative in that position. You can't go from having a positive base into having a negative answer just by using an exponent. Okay? Hope that makes sense. I'll try another one. All right. So let's take another example because I know you probably need to see another one. Let's say we have number 4. Okay? We have a base of 5, but we don't have that on the other side. Okay? So instead of just dropping log base 5, we're going to actually use it. We're going to use it as a base. We're going to use 5 as an exponent. All right? And then we're going to set it equal to 3 minus x. So all I did there was log is base. This is the answer, which is what I set it equal to, and the exponent, remember, okay? So 5 to the 5th power, need to figure that out. Okay, some big number. 3,125. Set that equal to 3 minus x. Subtract your 3. 3 negative x is equal to 3122. So x is equal to negative 3122. Okay, so let's see if that makes sense. If I plug a negative in right here, you're going to get 3 minus a negative, so it's okay. You can have 3 minus a negative, but it's going to become a positive. All right? And it should all equal out. So that looks legit for an answer for x. So we're not saying that you can't have a negative x value. What we're saying is it can't be negative once you plug it back into that position. Okay, you can have a negative exponent. You can't have a negative answer when you're dealing with these problems. Okay? All right, and then back to number 6. Here we have another example where you have logs on both sides. You're able to just drop them, set x minus 5 equal to 3x minus 25, and solve. So in this case, I'd get 2x on this side. I'd get 20 over here, and x would be equal to 10. I do want to plug that in for x, just to make sure. Okay. 10 minus 5 is 5. And 3 times 10 is 30. 30 minus 25 is 5. So that looks legit. X is equal to 10. Okay. Hope that was helpful. Okay, so I'm going to show you a few more equations where you are going to need to use your properties that we talked about at the beginning of this video. In this problem, we've got log base 7 of n equal to 2/3 times, that's a times, log base 7 of 8. And you're probably thinking, oh, let me just drop that log base 7. And I agree with you, I want to do that. But this right here needs to be relocated. Okay, so if you remember from the beginning of the video, if you have a number out front, it's actually a power at the back of the log. Okay, so what you can do is you can rewrite it as 8 to the 2/3. It's an exponent right there. Okay, so in doing that, you're able to then drop your log base 7, and set n equal to 8 to the 2/3. And I do want you to keep going. If you recall, 2/3 means what? Remember, the denominator is the root, the numerator is the power. So I'm going to take the root first. I'm going to take the cube root of 8, which is 2, and I'm going to square it, leaving me n is equal to 4. Okay, so that was an example of what to do when you have a number out front. You need to move it to the back before you drop your logs, okay? All right, on the next example, you've actually got some addition. Log base 6 of x plus log base 6 of 9 is equal to log base 6 of 54. And you're probably thinking, oh, I want to drop those logs, but hold on. Before you actually drop the log, you need to condense this side. Remember what we talked about. You can condense logs and you can expand logs. In this case, we want to be able to condense it so that we can drop the log base 6 and set our answers equal to each other, okay? So if I have a plus sign between the two logs, I can rewrite this as log base 6 of 9 times x. Remember, a plus sign in a log means a multiplication problem. All right, and so we have log base 6 of 54 over here. At this point, you're able to drop your logs, set your 9x equal to 54, and divide. X is equal to 6. okay? And don't forget, you do want to, plug it back in right there and make sure you keep checking, okay? All right, it makes sense. All right, and let's do a few more because I know these are new for y'all. Okay, let's say we have another one where we have, okay, so we have log base 9 of 3u plus 14 minus log base 9 of 5 equal to log base 9 of 2u. All right, so obviously we want to be able to get rid of all these log base 9s so we can solve. But you see a minus sign, you need to divide. So before we try to drop the logs, I want to see this on your work. Log base 9 of your numerator would be 3u plus 14 divided by 5 set equal to log base 9 of 2u. Okay? And so now that you see that, you're able to drop your log base 9. You're going to have what we call a proportion. So you're going to need to do what? Cross multiply. Okay? So we're going to crisscross applesauce. We're going to get 3u plus 14 is equal to 10u. And that'll allow you to keep solving. We're going to minus the 3u, get 7u equal to 14. Divide by 7, u is equal to 2. And again, plug it back in. 3 times 2 is 6. 6 plus 14 is 20. So if that was 20 and you divided by 5, you would get 4. And then if you plugged a 2 in right here, you'd also get 4. So it all works out. U is equal to 2. Okay? All right. Let's do another one. All right, so in this example, you have log base 10 of 4 plus log base 10 of w equal to 2. If you notice, you don't have logs on both sides like you did in the previous example. So we're not going to be able to just drop log base 10, but we still can rewrite it. And at that point, hopefully you'll remember what to do, okay? I still want to condense this side into a smaller log. So what I'm going to do is just rewrite it as log base 10 of 4w, 4 times w. Remember, if you see a plus sign, it means you can multiply to condense, equal to 2. Okay, so at this point you're thinking, okay, I can't drop log base 10 because I don't have it on both sides, but what I can do is rewrite this as an exponential. So what I'm going to do is use 10 as my base. Remember, log is base, answer, exponent. So I'm going to rewrite this as 10 squared equal to 4w. And that's going to allow me to solve for w. I'm going to get 10 squared is equal to 100. Divide by 4. W is equal to 25. Plug that in. Multiply. It all works out. Okay? W is equal to 25. Okay, so our last problem is what I would consider a more difficult problem because if you notice, I cannot condense this side right here. Do you know why? It does have subtraction, but we're missing the log base 2. So you cannot condense that. But what I could do is maybe trade positions. That might work. So I'm going to move this log over here and the minus 1 over here. So they're going to switch sides, okay? Okay, so that all I did was I moved log base 2 over of 1 minus 2y and moved the negative 1 over to the other side as positive 1. That's going to allow me to condense the left side. I'm going to have to use division, so log base 2, since I see subtraction, I'm going to have 5y plus 2 on top divided by 1 minus 2y on bottom. At that point, you're thinking, oh, I can drop the log. Not so fast, okay? You don't have log base 2 on the right. So again, what you can do, since you can't drop the log, you're going to have to use it. Again, the log base 2, remember, log is base, answer, exponent. So we're going to rewrite this as 2 to the first is equal to 5y plus 2 over 1 minus 2y. I would take the left side, go ahead and write that as a fraction because you're going to cross multiply on the other slide. Okay, so I'm going to cross multiply on the next slide. Okay, so I'm going to cross multiply that. 2 times 1 minus 2y and 1 times 5y plus 2, which 1 times 5y plus 2 is just 5y plus 2. So I'm going to distribute 2 minus 4y is equal to 5y plus 2. Going to add 4y to 5y, get 9y. Going to subtract 2 from 2, get 0. So it looks like my answer is going to be 0, which is possible. Don't panic. We are going to go back and plug it in and make sure. Okay, so I've rewritten it with 0 plugged in. This would be 5 times 0, which would be 0. 0 plus 2 is 2. So on the left, you'd have log base 2 of 2. You can actually find a value of that. Log base 2 of 2 is 1, because 2 to the 1 power is 2. So 1 minus 1 on the left is what I have, which is 0. Okay? Over on the other side, I have 1 minus 2 times 0, which is going to be 1. Once you 2 times 0 is 0. All right, so on the other side, we have 2 log base 2 of 1. All right, well, what exponent, remember, log base 2 of 1 equals some exponent, okay? What exponent will turn anything into a 0? Right? 2 to the 0 power will give you 1, basically. I'm sorry, I'm trying to say that in the right way. Log base 2, I'm running out of room. Log base 2 of 1 equals some exponent. What exponent will give you 1 as the answer? And that answer is 0. So 0 equals 0 in this case. It does check out. But that would be, I would consider that problem to be a more difficult problem. You probably will only have a couple of those. On all of these problems, I need you to work them out, show work. This is probably the most difficult worksheet we've had so far, okay? Ask questions if you have it. Y'all haven't asked me any questions, so I don't think you've been having any trouble. But I know this is more difficult, but this is important because you will see these in your next math class and on the ACT. Okay? All right, until next time. See ya.